You just pulled a spark plug out of your engine, and the tip is covered in tiny silver droplets that look like melted metal. If that is what you are seeing, your engine is already gone. But before it ever gets to that point, the plug passes through 6 earlier stages, and each one tells you exactly what is happening inside your cylinders. A spark plug cannot lie. It just shows you, in color, what is really going on. So here are the 7 levels, from a perfectly healthy engine to total mechanical failure. We are going through this in order of severity. Level 1 is the engine you wish you had. By level 4, you are looking at real damage. By level 7, the engine is finished. Catching the problem at level 2 costs almost nothing. Catching it at level 6 costs an engine. Level 1, the ideal condition. The tip looks light cocoa brown, tan, beige, or a soft light gray. The porcelain insulator is clean. The electrode is sharp. No deposits, no soot, no shine. This color means the air-to-fuel ratio is correct. The cylinder is reaching its proper operating temperature, and ignition is firing cleanly every cycle. In older carbureted engines, this was harder to achieve because tuning drifted with weather and altitude. In modern fuel-injected engines, the computer adjusts the mixture in real time, which is why a healthy plug today usually comes out closer to a light tan than the deep mocha brown mechanics used to look for in the 1970s. One exception: if the plug is completely white but clean, with no crust or blistering, the engine just has not been run under load long enough to develop the typical coloration. Short trips at low RPM never give the plug a chance to color up. That is not a failure. If your plug looks like this, put it back in. Everyone else, the news gets worse from here. Level 2, dry matte black. The tip is coated in a soft, velvety, dry layer that looks exactly like chimney soot. Run a finger across it and it smudges, but it is not greasy. The engine is running rich. Too much fuel is entering the cylinder, or not enough air is reaching it, and the unburned fuel is leaving carbon behind every combustion cycle. Usual suspects are a heavily clogged air filter, a stuck choke, or a carburetor or injector that has drifted out of tune. There's also a less obvious cause. If the spark plug itself has a heat range that is too cold for the engine, it never reaches its self-cleaning temperature and just fouls itself. A rich running engine is the most common diagnosis on this entire scale. It wastes fuel and fouls plugs fast, but the damage so far is 0. Move up one level though, and that changes. Level 3, shiny wet black. The plug is still black, but now it is wet and greasy, coated in something thicker than soot. That something is engine oil. Liquid oil is making its way into the combustion chamber and burning along with the fuel. In a 4-stroke engine, this is mechanical wear talking. Worn piston rings letting oil sneak past from below. Degraded valve stem seals letting oil drip down from above, or a blown head gasket allowing oil to cross into the cylinder. None of those are tuning fixes. They are repair bill fixes. In a 2-stroke engine, the same color usually means something simpler. The oil-to-gas fuel mixture has been blended too heavy, and the engine is just burning excess oil because it was told to. Drop the ratio, and the next plug comes out clean. Level 4, stark white. This is the one mechanics see and tense up. The porcelain insulator looks chalky, bright white, almost bleached. The electrode might show blistering, melted lumps or pitting near the tip. Sometimes the surface is dusted with tiny glittering specks that look like crushed glass. The engine is running lean and burning dangerously hot. Lean means too much air and not enough fuel, which sounds counterintuitive because most people assume more air is good. It is not. Without enough fuel to absorb and carry away the heat of combustion, cylinder temperatures climb past the design limit of every component in there. Those glittering crystals on the insulator are the warning sign nobody wants to see. They are the visible signature of engine knock, the technical name for detonation. Detonation is when the fuel does not burn smoothly. It explodes uncontrolled. Each event hammers the piston, the rings, and the bearings. With a shockwave the engine was never designed to absorb. Sources include a vacuum leak, a failing fuel pump, a clogged injector, or, in tuned engines, an incorrectly mapped ECU. Level 5, the shockingly clean plug. This one is sneaky because, at first glance, it looks like a good thing. The plug comes out almost spotless, like it has been steam cleaned. No soot, no color, no deposits at all. But this is one plug out of one specific cylinder, and the other plugs around it look normal. That contrast is the diagnosis. Coolant or water is leaking into that single cylinder. During combustion, the water flashes into steam, and that steam literally washes the deposits off the spark plug. The source is almost always a head gasket starting to fail between a cylinder and a coolant passage, a cracked cylinder head, or, in rarer cases, a porous block casting. The reason this level is more dangerous than it looks is that owners often miss it entirely. The plug looks clean. The engine might still start, but coolant is draining into a cylinder every time it runs, and the engine is one bad afternoon away from hydrolocking. That is when liquid coolant fills the cylinder and the piston tries to compress something that cannot be compressed. That is how connecting rods bend. Level 6. Thick light crust. The tip is covered in heavy, crusty, off-white or yellowish deposits. The crust is dry, but unlike the soft soot of Level 2, this stuff is thick enough that you can scrape it with a fingernail and feel resistance. The engine has been burning excessive oil for a long time, or low-quality fuel, and oil are being run through it. In two-stroke engines specifically, uncertified aftermarket oil and stale fuel produce exactly this kind of ash buildup. In four-stroke engines, it usually means oil consumption has been going on for so long that the combustion chamber is now lined with mineral residue. The engine is still running, sometimes still running well, but the internal damage has been compounding silently. Ash deposits raise compression unpredictably, create hot spots, and dramatically increase the risk of pre-ignition, which leads directly into the final level. Level 7. Metallic gray. The plug comes out dry, looking gray rather than black or white, and fused onto the surface of the electrode are tiny silver droplets. They look like solder or molten beads, frozen mid-flow. That is exactly what they are. Those droplets are aluminum. Molten aluminum that was inside the combustion chamber long enough to splatter onto the spark plug and solidify. The only way that happens is if a piston is scoring against the cylinder wall, or if the engine has already started to seize. The aluminum from the piston crown or the cylinder lining literally melted under combustion temperatures and bonded to the plug as it cooled. There is no tuning fix at level 7. There is no quick repair. By the time the plug shows metallic gray, the cylinder is damaged, the piston is damaged, and the engine is in the final stage of catastrophic mechanical failure. The job from here is a teardown, a rebuild, or a replacement engine.